Good morning, dear students. Myself, Dr. Lingaraju, Department of Physics, Government First Aid Degree College, Tumkur University. In BSc topic on physics, we will discuss today's topic is pulsed and tunable lasers and also its applications. So last class we discussed about a solid state laser, that is a ruby laser, and also a gas laser, that is a helium neon lasers. Based on these basic knowledge, so today we will going to understand some semiconducting lasers and also molecular lasers. After discussion of all these things, so we are get the information about a semiconductor and also molecular lasers. So next thing is, so first is semiconducting laser. That is also here we call as a pulsed lasers. So that is a example for this one is carbon dioxide laser. So it is a very efficient laser. It is a 4-level molecular laser and operates at 10.6 micrometer infrared regions. So construction of this one is, so here you see this is the construction of the diagram. The arrangements of this one is, a typical carbon dioxide laser is shown in a figure. It is basically a discharge tube having a bore across the cross section of 1.5 millimeter and the length is about 2.6 millimeter. So the disc is filled with a mixtures of discharge tube will be mixed with the mixtures of carbon dioxide and also nitrogen and helium gases. Helium gases in the ratio of 1:2:3. So of knowing this one, so just here we are going to discuss in a working process. So the working process is, you can see in a 4 energy level. This is the ground state energy level. This one is the excited state energy levels. So this one is the metastable state energy levels. So these are all also a small kinds of a metastable state energy levels. Here the light will takes the transition. At the time of transition between this level to this level, E5 to E4, so it releases the energies that is having a 10.6 micrometer or 9.6 micrometer. They having a monochromatic radiations, that is we called as carbon dioxide. So that one is here you can see it. So in has shown the lowest vibration level of a ground electrons, energy state of CO2 and N2 molecules, the excited states of a N2 molecule in metastable state, and it is identical in energy level to vibrate level of CO2 molecules. So that one is we can observe in the E5 energy levels. So next concept is tunable lasers. It is also we called as a semiconductor diode laser. A semiconductor diode laser is a specially fabricated PN junction device that emits a coherent light when it is forward biased. The construction of this energy level diagram is like that. You see P-type, N-type, and also a laser beam where it is coming active medium between a P-type and N-type, and also the polished faces. The construction of this one is, a semiconductor laser is a single crystal of GaAs with a heavy doped P and N sections. The N section is obtained by doping with the tunable and P junction by zinc. The construction of dopant is very high at the order of 10 to the power of 17 atoms per centimeter cube. Each of the size is 1 millimeter and PN layer has a tube width of 1 millimeter to 100 millimeter. A pair of parallel planes perpendicular to the PN junctions are polished, acting as a reflecting mirrors, which provides sufficient reflections. The other pair is roughed to suppress reflections and they do not develop any lacing process. The end faces of PN junction is provided with a electrodes to facilitate forward bias voltage. So this is the diagram of this concept. The working process is, you see, the working process in this diagram, you can observe it. A semiconductor laser made up of a GAS with a specially doped phosphate acts as a laser for visible light. So, and also here we can observe in the second working construct, if a semiconductor is at a absolute zero temperature, the conduction band is completely empty and valency band is completely filled state as shown in the first diagrams. So the next second diagram is when a p junction is forward biased, the electrons from the valency bias is conduction band, but this is an unstable state with within the short time of 10 to the power of minus 8 seconds. The electrons drops at lowest level in the same batch. So knowing these two concepts, we can observe some applications of a lasers. So in the lasers, they are used in fundamental research. They are used in the entertainment of electronics. So electronic devices regarding that here we are going to use it. Industrial work like a mechanical work, welding, cutting, drilling, for all this purpose we are going to use industrial work. In the astronomy also they are going to identify the length of the stars, the distance of the stars, or any all celestial bodies identifications. We are going to use it laser light radiation in astronomy because it is because of a monochromaticity. Next is low power semiconductor laser are used in CD players. Very high power lasers are used to bring out about a thermonuclear reactions. Most important one is used to get the three images of the objects in the process of holography. And also, so the laser light radiation is in the medical field is also they are using to identify the foreign items inside the body. So without using any kind of a laparoscopy or experiment or a surgery, only using of a laser radiation, they are going to find out so many different kinds of a very small values of a particles. That is also one of the very important applications we can observe in the medical field. So next year we are going to discuss some very important multiple choice questions. The first one is what type of laser is used in CDs and DVD players? So there is a semiconducting lasers. So next is what type of a laser is used more widely in industrial materials processing applications? Usually a carbon dioxide lasers. So next is stimulated emission by recombination of injected carriers is encouraged. Stimulated emission, that is in a semiconducting injection layers. In semiconductor injection layer, narrow line bandwidth is in the order of around 1 nanometer and less. So these are all the concepts what here we are going to study in a tunable and also a pulsed lasers and its applications what here we studied about lasers. So these are all very important concepts for the types of lasers. So what here we learned the examples of lasers. So these examples are very knowing things, daily life what here we are going to observing. Because nowadays from the laser we are utilizing so many important applications, especially in optical fibers. So we are going to pass the signals from one place to another place through a optical fiber under a total neutron deflections. There is also very important applications what here we are observing from lasers. And also in the military purpose also. In the military purpose, they are going to identify the submarines inside the sea. If any neighboring states or neighboring nations or if they are attacking through a sea, under the sea, so they are going to identify from the laser light where it is there and how much depth it is there. Everything they are going to calculate in laser beam, because the laser beam also it travels in the maintaining a monochromaticity under the CA also. So far, we are going to discuss all these things, the applications in a lasers and also its applications. So thank you, one and all.